Okay, hello. This is a solutions for our week 4 homework assignment, or actually the solutions for our load calculations involving actuators. And right now we're going to work this problem number 3 here. I've copied it. I've copied it over to my OneNote so we can write. It says here that the Pololu 99-to-1 metal gearbox D25D54L millimeter provides 91 gear ratio. We assume a train efficiency of 92%. The motor produces 1 ounces of torque. What output can we find at the motor at that speed? I just pulled this off their website, and this is one of their typical motors. I did make up that efficiency value. I think that's a reasonable expected efficiency for a motor like this. So I'm jumping to the note page. I'm not going to pull it up here, but I've got a page from our notes, the one that looks at torque, force, torque, work, energy, and power calculations. And I see that for gear trains, I know that power out equals the power in times some efficiency. Of course, you can't exceed 100%. That power out is my torque out dotted with my angular velocity out. Power in is torque in dotted with angular velocity in. Of course, I need that efficiency. I'm going to assume that these are both in the same direction, which means my dot product can reduce to a scalar product of magnitudes. And when I do that, I will rewrite this as my torque out divided by torque in equals my efficiency times my omega in over omega out. My kinematic relationship here says that my ratio of omega O over omega in is the, we'll see this later, but let's see, what did I call in the notes? I'm looking here, see what I said in the notes. Well, that's what we're calling the gear ratio. And typically, let me comment on this gear ratio. That would be, if you care, that's the number of input teeth over the number of output teeth, just as an aside. We'll look at gears later a little more. And in this case, it said the gear ratio is 99-to-1. So that means that the input rotates 99 units, and the input rotates 1 unit. So this would be my ratio. 1 output rotation equals 99 input rotations. So that's the way to think about this when you're given a gear ratio. There's not a standard. Commonly, they're given 99-to-1. You'll see those notes. Sometimes you'll give the gear ratio always listed as greater than 1. Sometimes you'll see it listed less than 1, but you just need to know how to read this. So in this case, the output goes 1 rotation for the input equals 99 rotations. That means that ratio is 1 over 99. So when I plug this in, that means I get 92% or 0.92 times, we said the ratio of the output over input is 1 over 99, or the input over output is 99. And then finally, okay, so that's what I get there. Or I can rewrite this. The torque out is 0.92 times 99 times the input torque. And the input torque was 1 ounce inch. And I said that was 0.7062 Newton centimeters. So my output torque is, let's calculate that. I've got MATLAB open. Oh, that's doing that. I guess I'm not going to have MATLAB. Sorry about that. We'll pause the recording for a minute. Actually, let's use our calculator. So it's 0.92 times 99 times 0.7062, or I get 64.3 Newton centimeters. And that's my answer.